Okay, so one thing to note is I've now moved the factorizing algebraic expressions further into the playlist because it's going to be more applicable when we get to quadratics and cubics to note factoring, and we'll meet this thing called the root factor theorem while we're there as well. One thing I did want to mention though while we're here is this idea of a difference of squares and cubes. Now, the difference of squares is something you would have seen at junior cert. To note that if we have the expression x squared minus y squared, where x and y can be really anything, they can even be functions of themselves, then we can express that as two different brackets, either the square roots of them added together, multiplied by the square roots of them subtracted from one another. So it's the sum multiplied by the difference. So it's pretty much everything other than division all in one go. That's stuff from Junior Cert. That's just kind of a JC recap, as I will title all of these. However, at Leaving Cert, you will meet the exact same thing, but with cubes. So with cubes is actually a fairly nice way to do both a sum and a difference of cubes. So the sum of cubes, x cubed plus y cubed, and the difference of cubes actually follow a very nice pattern. So for the sum of cubes, it is either x plus y times x squared take away xy plus y squared. So note that the first sign remains the same, but this guy in here is different. And hopefully you can see the pattern to when I say that the difference of cubes is x take away y and x squared plus xy plus y squared. So I'm not really going to go into too many examples. If you've done difference of squares, then difference of cubes is just subbing in a formula. Just remember taking the cube root instead of the square root. You can look back in your previous textbooks or notes to remind yourself on examples involving the difference of two squares.